following Chalk Talk is brought to you by Isolite, the emergency lighting experts. Stay educated, my friends.
Good afternoon or good morning, depending on where you're joining us in the country. Thank you for joining us for our April Chalk Talk. I'm Greg Keel, along with Matt Bird, and our host today is our sales support engineer, Tom Deutsch, who's been hard at work at this project for us. As you can see, our topic is inverters versus generators. And this is just the tip of the iceberg on some stuff that Tom's been working on, and I don't want to steal his thunder because he's going to talk about it in the presentation here today. But as you know, being familiar with Isolite, we do manufacture inverters. We obviously are going to promote inverters, but we do realize there are use cases where a generator may make sense and may already be on the site that you may want to tie your emergency lighting system into. But the point of this presentation is to give you some considerations. We want to make sure that we're providing the proper solution for a project, even if it is something that we may not provide ourselves as a manufacturer. But again, thank you for joining us, and I'll hand it over to Tom Deutsch.
Thank you, Greg. What's going on, everybody? Welcome to another exciting Chalk Talk. My name is Tom Deutsch. Today we are going to be talking about inverters and generators. Specifically, we are going to be comparing them to each other in a couple different ways. We're going to look at how they differ in terms of the general pros and cons, but also maintenance, their risk profiles, as well as how they comply with NFPA 101 as it relates to life safety. And then finally, we're going to talk about the presentation that I've built here. So some basics here. There are a couple of different ways that you can accomplish emergency lighting. So primarily you have the, as we call them, batteries everywhere solutions. That would be emergency lights and battery packs. Then you have the centralized solutions. That would be what we're talking about today, generators and inverters. Inverters, these are connected after the panel and before the emergency circuits. They are going to pass through utility power when everything is normal and okay. And then during an emergency, they are going to transfer internally to battery power. Note that downstream lights will always see power minus a approximately 2 millisecond blip, and then after approximately 90 minutes. Note that there is also a really low level of variation across the industry as it relates to inverter for the most part. Isolite makes fantastic inverters, and our competitors also make perhaps somewhat less fantastic inverters, but they do perform pretty much the same function and are going to fit within a one-line diagram very similarly. A lot of the maintenance will be pretty similar. Generators, on the other hand, there's going to be a little bit more variation, I should say a bit more variation across the industry in terms of what you're getting with a generator. But in terms of the basics of how they're going to fit in within a one-line diagram, they are connected separate from the panel before the emergency circuits, and we're going to require a transfer switch, a big ATS to detect the emergency and then transfer everything over from the utility to the generator. Note that still downstream lights will always see power because that's what we need under NFPA 101. But now this time, instead of 2 milliseconds, this is minus a 5 to 30 second blip, and then after approximately a few hours to even a few days, depending on what sort of generator you have. There are two main types, diesel and natural gas. So you could have some really, really long run times if you do have natural gas because you have a constant flow of power going into the thing. Diesel, you're going to require some sort of tank, and then you're sort of limited to whatever you have in your tank unless you have someone who's going to come and fill up your tank for you. There are two basic ways that you can mount these generators. That would be indoors and outdoors, and there's going to be some additional considerations depending on which way you go there. For the operation itself, I want to mention exactly what these systems are because they are quite different in terms of what's contained within each thing. So when you buy an inverter, what you're getting is the inverter, so the thing that brings AC to DC and then DC back to AC. You're getting a bank of batteries, a transfer switch to perform the function of switching between battery power and utility power. you are getting a panel. Not everyone realizes this, that these inverters, they come with an electrical panel inside of them. So sometimes when you see things drawn out in prints, maybe they were planning for a generator, or maybe they just are writing out in the panel schedule. It looks like you'd have a panel feeding the inverter, which then feeds another panel, and that is a way you can do it. You can certainly do that, but especially our E3 Mac, our E3 Max, they come with breaker panels internal attached to the units, so you don't have to worry about that. You get an input breaker and a number of output breakers there. Also, inverters are testing and documentation machines, so they're going to do all of that monthly and annual maintenance required per NFPA 101 for you. So you don't have to, if you're the facilities, the maintenance crew, you don't have to go around and perform the maintenance, especially compared to how you would have to for those batteries everywhere solutions. It's one point of maintenance, and then also it's awesome that these things do all of that testing for you and documentation. So you can really set it and forget it. Generators are going to be a lot different. So essentially the generator is equivalent to just the batteries stored within the inverter, because all of that extra infrastructure that the inverter is providing, what we call an inverter, is going to be what you'd call an EPSS, that's per NFPA 110, for a generator. A generator is an EPS. It is just an emergency power supply, but it's not the entire system. The entire system that's required to have a functional backup program here is going to include switchgear, so your ATS. It's going to need its own panel, so that's not something integral to the generator. You're going to need controls, annunciator, disconnect, other supporting material, namely a generator port. So that's NEC 700.3 mandates that you need to be able to supply temporary power in the event that the generator should experience any issues. So that temporary source of power needs to be able to do everything that the permanent one does. So there's going to be a lot of infrastructure required with that as well. Some additional considerations: if you're going outdoors, you're going to need to mount this thing on a concrete pad, and you might be required to provide a fence for it. Also, we have to be aware of noise ordinances, so you might have to deal with that. If you're indoors, you're going to have to deal with exhaust routing, soundproofing, potentially dealing with temperatures as well. Trying, to keep everything safe for the occupants in there. We now have a carbon monoxide hazard. So typically we want to mount these things outdoors if possible. Makes life a little bit easier. Pros and cons associated with each of these systems. So for the generator, the pros, these are reliable for those extended run times and super high capacities. We don't have any batteries, but we are going to have to deal with whatever complexities arise with the fuel. If it's diesel, it's going to be continuing to fill up that tank and making sure that we have the proper amount of fuel contained there. If it's natural gas, making sure that supply is up and working at all times. But there are some cons associated with these as well. So all of that additional hardware is going to bring a ton of complexity, especially as it relates to install and design of these systems. We do need to deal with the fuel. We have to deal with the fact that these things are physically quite large. A lot of times that won't be an issue if you do have space outside, but it is a consideration, especially if you want to mount one of these things indoors. They're probably going to need an entire space, a large room dedicated to them. They are quite loud, and that can lead to code issues, especially as it relates to sound ordinances, and then also with not disturbing the occupants of your building. So when an inverter pops on, you're hearing absolutely nothing. When a generator pops on, everyone in the neighborhood knows it. And then also the biggest thing is going to be those long transfer times. We're here talking about life safety, and in terms of life safety, you need those transfer times to be under 10 seconds. If it's not, you have a huge issue. Inverters, so the pros here, these are designed specifically for emergency lighting. There's nearly zero transfer time. Again, 2 milliseconds. We're never going to go over that 10-second maximum that we have. They are extremely low maintenance, especially related to generators. This eliminates all of those testing costs because they do that for you. They're inexpensive compared to generators. They're less expensive, completely customizable and easy to configure, much, much easier to install, especially considering the whole system. Some of the cons is that these are designed for life safety. If you're trying to back up an entire building and Maybe you're able to put the life safety on that generator. If you're backing up a whole building, you probably have a generator that's not going to kick on within 10 seconds. It's not what it's designed for. So in that scenario, you're probably going to need an inverter to go alongside your generator. We've certainly seen that happen a ton, where a building thinks that they can just go with a generator, but it turns out we need an inverter too, because we're not kicking on within 10 seconds. But if you want to consider a con to these things, we're mostly, I say mostly because it is, we're not entirely limited to life safety, but we're mostly limited to life safety. Generator maintenance, let's talk specifically about how these things compare in terms of maintenance. So with a generator, you are required to provide weekly, monthly, and annual testing and maintenance, and that does include some pretty intense work for you there. So you need to, every month, you need to go and examine this thing, make sure the voltage, frequency, oil pressure, that there's proper load on it. If there's not proper load on it, you actually have to bring in a load bank and test the thing with full load, or at least 30% of that nameplate kilowatt load, just to make sure that the thing actually works the way it was intended to. And then you have to deal with any alarms or abnormal conditions. Annually, it needs to be pretty much a full breakdown of the whole system. You need to check all of the oil, do an oil fuel filter change, air filter, the coolant, battery, just so much. You have to check the entire system head to toe. That's not something we'll find with an inverter. Again, we're dealing with an engine. There's a lot of mechanical moving parts and a lot more points of failure. Many, many more points of failure. That's why the code makes us do all of this. NFPA 111 compared to NFPA 110 for generators is a lot less stringent. They don't have to care about as much because inverters are intrinsically a lot easier to care for. So NFPA 111 basically just says we need to maintain the physical connections of the batteries and the cleanliness of the room. In the past, there was some stuff with battery acid maintenance. On rare occasion, you might need to deal with making sure a room is properly fireproofed if it's a certain occupancy type. But for the most part, it's really just making sure that nothing catastrophic is happening around the inverter, making sure that there isn't going to be any arcing from the battery terminals, and then making sure that the room isn't disgusting and full of dust. And that's kind of it. There's no maintenance schedule there. They just are looking for those blatant failures. Let's talk for a second about the risk profile with both of these devices. So the generator risks, there's a ton, way more than I could list on this page, especially without boring you, but fuel degradation over time, fuel is going to go bad. A lot of times these things are going to sit not running for a long time, and I'm sure many of us are familiar with, if you leave your car not running for an extended period of time, there's a decent chance that when you go back to that car, it's not going to run. Maybe it's that battery that's sitting outside getting bad, dealing with the weather. Maybe it's something from the engine. Maybe it's some of the electronics. Again, these are complicated systems, and there's just so many different points of failure. Human error, again, if we're dealing with oil changes. I got an oil change one time, and they forgot to put oil in the car. It sounds crazy, but when you're dealing with human intervention to that scale every single year at the very minimum, there's going to be, at some point, somebody's going to mess up working on these things. And then, of course, there's the increased scrutiny from the inspectors because they have to. These are more intense systems. The inverter risks, really simple, predictable, diagnosable battery aging. We know it's going to happen. We can predict the schedule at which the batteries will degrade, and we can plan to replace them ahead of time. Potentially, maybe the electronics are going to go in the event that that does happen, and it is quite rare. It's really easy to replace them. It's super modular. There's only a couple of boards and a couple of fuses in there, and pretty quick to get those swapped out and get things back online. In general, the inverter risks are predictable and monitorable, whereas those generator risks are going to be latent and event-driven. All of a sudden, something bad happens. You didn't see it coming, and now everyone's scrambling to fix the issue. And then the final point, the most important point here, and you have heard me bring it up already, but the transfer time. It is absolutely a concern on every single job that has a generator that we're trying to run life safety on. Should be your number one concern to make sure that the system is going to actually come on within 10 seconds, because that amount of time is pretty difficult for generators just because there is a whole sequence that has to happen. So the utility power fails, and then the ATS is going to sense that loss. That takes a couple seconds. Then the system has to boot on, the engine has to actually start up. That takes a couple more seconds, and then it needs to stabilize in terms of its output. That's going to take a couple more seconds, and then finally the ATS can transfer everything. That's going to take at bare minimum 5 seconds, and at maximum it could be 30 seconds. So it can take a ton of time for these systems to boot on. Absolutely need to make sure we're kicking on within 10 seconds. In summary, inverters are devices specifically built and optimized for efficiently accomplishing life safety. Designed to come on right away, designed to run for 90 minutes, maybe a little bit more, but it's specifically tailored and made with the purpose of accomplishing life safety, whereas generators are these generalized solutions which are not ideal for life safety because of all of that maintenance and all of that significantly increased compliance risk. Other than that, that's not to say they don't have their place. It's nice if you want to back up your whole building, but again, as I said, for your life safety, you're probably then going to need an inverter anyway. And we are here talking about life safety, so as it relates to life safety, it just makes so much more sense to go with an inverter. This is just a small part of a full 1-hour presentation that I've built, and I'm just wrapping up now some of the final changes and edits. I'd love to give this presentation to you all, so to all of our reps out there, let us know. I'd love to get the whole group together. We can give one of these presentations. For all of our specifiers out there, all of our engineers and architects, I am also going to be turning this into an AIA course. I just need to wait for their approval, but that is imminent. As always, there will be a follow-up email with a link to this video recording of everything you've just seen here today, as well as a PDF file of this presentation. I'm Tom Deutsch, and together with Evan Ackman, Greg Keel, and Matt Bird, we're here for you guys. Please reach out should you need anything in the future. Thanks for listening. I'm now going to stick around, and if you have any questions, please post it in the chat or the Q&A. Thank you.